we're designing things for multiple generations to enjoy. We tend to react about, well, I want an immediate impact. And we can absolutely do that in our field. But I think even more fundamental is that we're creating impacts that will last generations. We have all sorts of civil infrastructure and buildings here in South Bend, Indiana that were constructed over 100 years ago, and we're still utilizing every day to enjoy a quality of life.
Welcome to the Level Design Podcast, a podcast for architects and engineers who want to thrive in this industry by creating more freedom, fulfillment, and financial security. Join us in uncovering how to restore value and honor to the unique people who choose to be designers and caretakers of our built world, and why it's essential to the future of our society, our industry, and our planet.
I liked problem solving. I did not know that I necessarily wanted to get into engineering. In fact, a university I really liked was University of North Carolina at Chapel Hill, and I guess I hadn't done enough research before I went down there as a high school senior. I said, I love this place. Where's the engineering department, just in case I want to major in that? And they said, well, you get in a car and you drive to Raleigh and enroll at North Carolina State. And they do have some engineering there now. But I like solving problems, but I wanted to go to a university that had a wide range of vocational majors. Ended up at the University of Dayton for various reasons and loved it there. Enrolled as non-committed, just a general engineer, not with a specific major. And like at a lot of universities, they have a first year discernment class where you get to do a little bit of taste of all the different engineering fields. And I really enjoyed building the model bridge and breaking it. I thought that was pretty cool. And I think I was probably attracted to working on big problems, and not just big as in important, but big as in tangible scale. So that really attracted me into the built environment AEC space. Came to like structural engineering, and as was becoming trendy at the time and has only increased since then, it's become quite fashionable for structural engineering companies, particularly in the building side, the vertical structural side, to require or prefer master's degrees. So I went to get a master's degree. And then I graduated in 2009, which was a terrible year from the perspective of becoming gainfully employed. But it was a defining moment for me. I learned a lot of resilience that I had not learned at that point in my life. And it was part of the drivers, I think, to keep myself diversified in future career options. And I can talk a bit more about that. It forced me to consider some options for my career that I definitely did not envision myself pursuing. And I sent out over 60 applications, only had a small handful of interviews. Half of them were from people who could not hire me, but they were just so bored themselves. They wanted to talk to somebody. But kudos to all of them right off the bat. They said, this is not going to end with an offer because we're laying people off. But I don't have any work today, and I just kind of want to hear what's going on with recent graduates. Ended up working for a small company that operated in a literal horse barn in Wakarusa, Indiana, called Frost Engineering and Consulting. Their overhead was very low at the time. They were able to hire me, and that's a company I'm still associated with today. And worked on a wide range of projects. And that was so important for me when I was young. Like a lot of maybe young engineers, I thought, well, I'm going to go become a specialist in something and just knock it right off the bat. I was put into a wide variety of environments around the country, worked in a wide variety of structures, ended up being the best thing that could have happened for my career. And I share that advice a lot with the young people I mentor now.
Did you find an advantage with not just being in academia, but also practicing?
Yeah. So currently I'm a full-time faculty member at the University of Notre Dame in the College of Engineering. I direct our professional master's program here. And at the moment, I also teach our senior capstone course. I've continued in my role at Frost Engineering part-time. So I'm now a part-time principal there, which is a bit odd. But again, it's a company that's found a lot of resilience and flexibility to survive and thrive in this industry. I'm at a tier R1 university. There is some major research that's taken out here. My colleagues represent not only fantastic world-renowned scholars, but also world-class teachers. So when you get into an environment like that, everybody just needs to find their niche. So what do I bring that's unique to this picture? And I think I found that the best thing that I can bring to my role as a faculty member is to retain some, finger on the pulse of industry. And I do that through interacting with our multitude of wonderful and generous industry partners in our capstone course. I interact with a lot of them as well when it comes to recruiting and hiring our students. But also, I want to have my nose to the grindstone at least a couple hours a week, so I understand how real projects progress, what technology is taking over. When I got back into academia, nobody used Bluebeam. Now it has taken over the entire industry, right? So if I hadn't kept practicing, a few hours per week, I probably would have missed the boat on that. But as it is, I'm well aware of it. We integrate it into our courses. Our students all have it on their computers or access it in our labs, for example. And I'm not the only one who pushed that, but that's just an example of I'm trying to keep up with the industry so our students are as prepared as possible for their careers afterwards.
That's awesome. So Scott and I talk a lot about mentorship and the youth and the difference in generations and their interest in A&E. And, there is a decline in interest, it seems. But you're in classes, you're interacting with the youth, so to speak. And what are you finding? Any patterns, any changes over the years of what they're asking, why they're in your class, why they're interested, what they want to do? And or is there a side that you're seeing where people are maybe losing interest or leaving altogether?
Yeah, this is the $1 million question in our industry right now. I've had a hard time finding numbers on this, but ASCE in the past few years has openly published articles about how enrollment in civil engineering programs in general has been reducing across the country. Now, I know of some schools that they're seeing increasing enrollment, but a lot of schools, including ours, it's tough to bump up the numbers in that space. The perception as to why we're having a hard time convincing young people to go into our industry is multifold. And I'll talk about how truthful I think these items are or how accurate they are in a minute. But here are the perceptions that high school, when it comes to tech, students see robots, they see computer programming, they see smartphone apps, and they don't associate any of that stuff with the built environment industry. They associate it with mechanical engineering, computer science are the two big ones. When the students do a little bit of research, they also see that civil engineers on average have lower starting salaries. Now, those salaries are coming up. And also, if you look at career growth, civil engineers can do very well and in fact can outcompete a lot of engineers in other capacities, but everybody's looking at the starting salary, right? I think we also have a meta trend that we're fighting in general, and this is not a problem specific to the built environment space, but demographically, we have an issue in higher education. There are far fewer college and graduate school age Americans today than there were back when I was college and graduate school age. And there's a smaller percentage of Gen Z who actually want to go to college in the first place. So a lot of universities have been, trying to recruit heavily from an international pool, and that's great. And I love working with people all over the world, especially if we can bring talented people here and keep them here. That's wonderful. But for various reasons, it's harder to recruit globally than it is domestically, right? And there's a lot more barriers towards getting students here in the first place if they're coming from abroad. So I think there's some meta trends that we're fighting there. In terms of the perception that high school students might have, I think some of that is true. It's very hard to take a skyscraper into a classroom, right? It's a little bit easier to take a computer app or a little robot or something like that. I think we need to do a better job of showing just how advanced our technology is. And tooting my own horn here, but I'm teaching a historic preservation class where I think a lot of students get into it thinking that we're going to be, mounding up mud and turning it into bricks or something like that. And actually, we're going to fly some drones around a historic building to figure out where the crack patterns are. And they're going to have to use ReCap and a few other software packages to basically identify the geometry, identify the damage that's, well above street level. We use pretty sophisticated hardware and software to solve the complex problems in our industry. We just do a poor job of conveying that, in my opinion. As far as the salaries, the good news is that I think this new generation is, even more so than millennials like me, interested in finding fulfilling careers where they can really, shape their communities in a positive way. I don't know that anybody really does that more than, people working well in the built environment space. So I think that's a message that works to our advantage. We just need to do a better job of selling it and promising them, they're not going to starve in our industry either. And there's fantastic career growth potential and salary growth potential. I mean, the things that I've been able to enjoy in my career the past 20 years have just been fantastic. And I'm curious about a lot of things in the world. I could see myself doing a lot of things, but it's hard to believe that I would find as much fulfillment in another career field.
I agree. And a lot of what we're doing here in this podcast is wanting to get or generating excitement for the youth about engineering again. I think as an engineering group in general, we have not done a great job of really speaking to this is just an exciting place to hang out for a whole lifelong thing. This is super fun. And it's not going away in the United States. This is an industry that is just on a growth pattern, solid growth pattern. Global climate change is going to drive it even steeper curve of growth. And this is just fun. And we wanted to start being better at, especially in this podcast, about talking about it more, about how fun it is to work in the built engineering space. And the money is to me, it's a business structure. Of course, we have a different business structure so they can make more money, but it's a temporary structural issue to me that's temporary, that currently the business structure is, in the last decade has caused this downturn in starting salaries. But it's coming, like you said, it's coming back up. And it's just a blast, and there's money to be made, and there's so much passion in looking at something that you contributed to building. I mean, it's just a wonderful lifestyle to walk around your communities and say, I was part of that.
It is. And the other way I sell it too is that, where's my iPhone? Well, it's tucked away, but everybody knows what an iPhone looks like, so I don't need to hold it up for exhibition. Fantastic engineered piece of technology. The people who have designed and built it, world-class engineers. But you know what? I've got an iPhone 13, which at this point is almost borderline obsolete, right? We're designing things for multiple generations to enjoy. And I think when people think about investments in their community, we tend to react about, well, I want an immediate impact. And we can absolutely do that in our field. But I think even more fundamental is that we're creating impacts that will last generations. We have all sorts of civil infrastructure and buildings here in South Bend, Indiana, that were constructed over 100 years ago, and we're still utilizing every day to enjoy a quality of life. In fact, particularly in the historic preservation space, there's this renewed interest in getting back into old buildings. People love sitting down and having a gastro pub burger and a microbrew next to a 100-year-old brick wall while looking at the old river, right? People enjoy that. So it's a really exciting time to be working in that space.
Yeah, definitely. There's roughly 100 million existing buildings in this country. We talk about that a lot, right, Miles? We're not tearing down 100 million buildings and rebuilding them. The environment couldn't take it, right? The environment could not take it. So we got to be saving these buildings and reusing them. And that's
well agreed. And the U.S. Green Building Council has made such fantastic strides with the LEED criteria. And of course, their stated goal was always that they become so incorporated into the building design process and regulatory process that they kind of become obsolete. And I've noticed a lot of people dropping, LEED after their names in the past few years, which is fine. I mean, that was the goal. But no matter how well we design and build new buildings, which we absolutely should be doing, you're never going to design and build a new building that's greener than preserving an existing one. The embodied carbon, the embodied energy is already there. So we need to be better stewards of our built environment in general.
Yeah, I'm so aligned with that conversation. And I mentor a lot of our engineers, they come to me with, hey, I want to build high rises. I want to design high rises. And I'm like, guys, it's moving towards AI. I mean, the structural engineering world or the architectural world, so much of this is going to be AI stuff. It's really not where the work is. The work is converting our existing stuff and maintaining it and reusing it and taking that existing value and making it current. And that's where the wonderful work is for engineering and architecture. That's where the work really is going to be so much fun.
I completely agree with you because there are very complex new builds out there. And I've been lucky to work on a lot of them. But I think when you are evaluating, restoring, prioritizing existing infrastructure, vertical, horizontal, whatever, it's more imperative that there are humans in the loop of that process. And that's important if you want to remain gainfully employed, right? If what you're doing can be designed and optimized with, pretty much just a few simple inputs into a numerical input structure, AI is going to take your job. So you've got to work in the space where humans have to be involved in ongoing decisions in the process in order to remain relevant. And I think that involves expansion, annexes, restoration, evaluation, require humans in the loop. Now, with that said, I know in the bridge inspection space, particularly my colleagues in New Zealand have been advancing this, but it's going to take over in the US as well. We are trying to train, our hardware and software to basically do these NBI inspections for us, right? Identify damage, particularly in a fracture critical bridge. I know the terminology has been updated, but I've been out of the bridge space for a few years. So apologies to my bridge colleagues that I've forgotten the new term. And I think that's a wonderful use of technology. And you know what? Maybe for regular inspections, there is a way to automate that, and we absolutely should. But again, you have to be out in the field and touching and measuring things and understanding all of the human and economic and social and logistical factors involved when you're getting into a restoration or a retrofit project. And it's very hard to just optimize those purely in a numerical program right now, which is what I like. I think a lot of young engineers are surprised to hear me say that what we do is as much of an art as it is a science.
Really? What do you think the disconnect is?
Well, I think a lot of 18-year-olds get into engineering because they like math. That was a big part of my reason. They think, and I remember thinking this way when I was young, and maybe I'm projecting a little bit, but in talking to early college students, I think a lot of them say, well, I like quantitative problem solving and I like math because I'm paraphrasing a bit, but I feel better about the world when I believe that there are black and white answers. And, something that's quantitative tends to lead me down that path. Whereas, what I'm learning in my philosophy class with the trolley problem, that's complicated, right? There's no good answer. And I tell them, well, on any complex project that you work on in our field, there's never a good clear-cut answer either, right? I mean, you're working with a lot of stakeholders and you're making your best guess, and you could have two extremely competent structural engineering firms design the same building and come up with very different solutions to resist gravity and especially lateral loads, right? It doesn't necessarily mean one is wrong. They just had different factors, parameters, and experiences that played into that decision.
I do find this a little bit, I don't know what your experience is, but maybe we can start having conversations about, this built environment is for the creatives too, not just the math students. So I would say I'm a creative, and I took engineering just so I understood how to be creative in the built world space. Engineering wasn't my primary. It was creative design was my motivator, and I took engineering so I understood, so I could create well. And I'm a little disenchanted with our constant communication about STEM, math, sciences, why you go into engineering or architecture. And I'm just like, you know what? It's actually for the creatives too. It really is.
I completely agree with you. And there's what I described about students liking math and getting to engineering might represent the majority, but it doesn't represent all of it. And I've had a not insignificant number of students who, I actually don't like the math. I went to design. I went to get into graphics and videography. So I'm thinking about a career change. I say, whoa, no, we need people with those skill sets and interests in our field. In fact, we have too few of them.
We have too few of them
these days. And not just for marketing purposes, but everything we do is spatial, and we are working in 4 dimensions on any notable project. And we need people who can design our way into those solutions.
Looking for a new opportunity? Interested in being part of an expanding network of independent engineers and architects who are thinking differently? Level Design Partners is on a mission to create prosperity for design professionals, the industry, and the world, using innovative business systems and a culture of collaboration. We believe that traditional education and firm structures want you to be a cog in their machine, depriving you of key skills needed to thrive, thus commoditizing an entire industry in the process. Gain access to skills, tools, and systems by partnering with Level Design Partners. Learn more at leveldesignpartners.com.
Nearly 60% is the latest statistic of engineers coming out of college in the United States in a built world undergrad. Nearly 60% within 5 years go into the work environment. Nearly 60% is this current number quit engineering altogether. And so we're bleeding out in this country. And one would say, what happened? Coming out of school, I mean, this, only half of them make it through engineering that start, right? So I talked to Miles. I said, there's this number thing where maybe 1 out of 100 of your nerdy kids, and maybe 5 out of 100 nerdy kids that you always admired in high school as a smart kid go into engineering. Only half of them make it through engineering. And then we lose another 60% of those in the work environment. And in civil, only 20% of them get licensed. What's going wrong here?
Yeah, I wonder, first and foremost, I do feel like engineering needs a rebrand of some kind, which we kind of talked about. And I wonder how, obviously we're kind of working on that. There's other people working on that, but it's going to take some time. And then especially earlier on, are we dropping the ball with the educate? Has the education kept up? Has the way we educate evolved with the times? I mean, I have no clue.
Yeah, what do you think of that, Kevin? That question?
Yeah, I was hoping those questions were rhetorical because I don't have a great answer for them either, but I'll take a stab at them. I did not know about the 20% statistic. I would be interested to see how those numbers, basically the 40% retention post graduation in engineering in general, and then I guess, the 20% retention through licensure, compare against other engineering industries. And is there something that the built environment space is doing differently that makes our numbers worse than in others? We all know that regulations, specifically licensure, are more stringent in our field than they are in any others. When you look at the proportion of students and just the raw numbers who take the NCES FE civil exam, it outpaces other majors. So I think some 6 month period last year, the latest NCES numbers, there were 3,500 or so people who took the NCES FE civil exam, and only like 2,000 who took the mechanical one, despite the fact that mechanical engineering departments tend to be a lot larger than civil engineering. And that's because we all know we have to get licensed. That's not as critical in other fields. In fact, nationwide, there are top tier universities who are dropping ABET accreditation from their computer science programs and some of their other non built environment engineering programs. And while I don't promote that, I can understand why. There's such a small percentage of the students who actually need it for their career path. So could that possibly be the cause of retention, the licensure process? I don't know. I do think it intimidates some students, but for all those who have been through us, it's really not that big of a deal. And as I encourage our seniors, the things that you need, yeah, you have to study for an exam and take it. Okay. That's an extra effort. But most of the things you need to do to become licensure, documenting your project experience, the growth of your responsibility, your networking so that you have PEs to write you letters of recommendation. These are things you need to be doing for your career anyway, even if you never get licensed. So 80% of the effort are things you probably should be doing anyway if you want to progress in your career. And yeah, there's an exam, and I realize that's not fun to take a few years after you graduated. The good news is I think this has been a great change in the industry, and hopefully I'm right and all the state boards are right and we see dividends down the road, is that a lot of states are decoupling the experience from the exam, meaning that you can take the exam whenever now. You still have to get the experience before you become licensed. And I have some colleagues who I know and trust who say, no, I don't think that's fair. I think you should have to get the experience before the exam. In my perspective, I think it's great to have young people who are preparing for an exam. The preparation process in and of itself is very informative. I learned a whole lot preparing for the SE exam, and I took it in my late 30s. So it was beneficial to the technical growth of my career. And secondly, it's an exam, and if a young person can prepare for it and study for it, okay, good. Let's just check that box and move on and make sure they get their meaningful experience before they get licensed. But it becomes exceedingly harder to set aside time in our lives to study and take licensing exams. I know this, having taken one in my early 20s versus taking one in my late 30s with 2 kids and a couple of jobs, right? So I think so long as we're still progressing through those benchmarks, the time in which we do them or the sequence in which we do them is probably less important. And I hope that somewhat marginal change effectuates some downstream benefits of retaining people in the industry. We'll see.
Yeah, one of the things that I noticed about what you're up to, the American infrastructure situation, I think Miles was surprised when I told him he owns more public infrastructure than he does private assets. So I think every man, I just ran numbers this morning, just going, what is this number? And I'm like, that can't be right. So I want to run the numbers again. But I came this morning, if I'm right, each man, woman, and child in this country owns about $2 million worth of infrastructure. Every man, woman, and child. And that's public infrastructure. Private buildings, like where you go to work, offices and factories, every man and woman and child represents about $4 million in private building stock. Is it somehow associated with $4 million of private building per square foot kind of thing? And I'm like, this is extraordinary to me, that either through business and or as a taxpayer needing to maintain $2 million of asset, and you need to be productive in the workplace to support $4 million worth of business infrastructure. That's a lot of responsibility. That's a lot of infrastructure. And we have a declining group of engineers, working in this country. And then we have this global impact of just building infrastructure, maintaining it is almost half of the carbon footprint. Somewhere between 8 to 10% of all carbon comes from making concrete. And now we have global climate change, which is going to have a migration effect. All the populations on the oceans and are going to be pushed into new in northern latitudes. And now we have to accommodate a shift in population through immigration and or climate change. So new infrastructure has to be built faster. And in this space, you need this thing called a designer to handle this human convenience demand. And we have this lackadaisical approach as engineers and architects, for whatever reason, about enrolling people in this wonderful opportunity of designing human convenience in this country. And I'm just, this has got to get fixed pretty soon. I just think it needs to get fixed pretty soon.
I will say, I've got a colleague from WSP who's a friend and fellow graduate from Notre Dame who's semi-retired, and he's very fond of coming here and telling all the young people, me and my generation already fixed all the easy problems. We left the hard ones to you. And I'll add on to that for anybody who is listening to this, the career growth potential in this field is fantastic. You can go anywhere you want. You want to be a technical designer in a big firm, tons of opportunities there. You want to be entrepreneurial and run your own business, heaps of opportunities there. The opportunities in this field are fantastic.
Absolutely.
Based on all of the problems you just described, right? Challenges create opportunities, and there aren't enough people going in there to solve all of these problems. So there's a lot of space to move around within our industry.
Well, tell us about it looks like your passion on new materials being utilized in the built environment.
Somewhat. So I'm very curious, and I like all aspects of the built environment. I find myself in our capstone project, partially advising on environmental wastewater treatment plant projects about which I know nothing. I'm a structural engineer, but I'm just so curious about how all of these processes are done. So I never sought out to be a specialist on any particular type of structure with any particular type of material. And what I found is that willingness to be curious sort of inevitably turns you into a specialist because you're willing to say yes and to get into areas where a lot of other people don't want to work. So, for example, when me and my teammates at Frost Engineering are, bidding on a project with a 4/1 multi-use residential build somewhere, right? Those are all over the place. That's a competitive space. You're going up against dozens of other firms, and we like that work, and we're very good at doing it. But there's a lot of other companies that also like that work and are good at doing it. And so I found in my career, and my teams both here at Notre Dame and Frost have kind of learned this too, that, do what you're good at and where you have less competition as well. And I have found that if I take the built environment time frame and I kind of ignore the middle and focus on the very, very new and the very, very old, there are lots of exciting projects, a lot less competition. So, for example, I work a lot with historic construction. So this is here in the lower part of the Great Lakes region, we have this yellow clay. So the reason Milwaukee is called the Cream City actually has nothing to do with their brewing heritage, as cool as that would be. It's because all their bricks are yellow because that's the color of our clay here in the lower Lake Michigan basin. And the buildings on campus here were actually built, the University of Notre Dame's campus, were built by priests and brothers who actually manufactured their own bricks in kilns alongside the lake here. And at some point they started importing them from out of state as well. But, masonry is a very complex material. A masonry wall is a composite structure. And if you don't really understand how the composite structure behaves, it can be very scary. And there are a lot of people in our field who unfortunately won't really engage that as anything other than a cladding material. They won't evaluate it for resisting out of plane or in plane lateral loads. And that's a major issue, I think, in the technical side of our structural engineering industry when it comes to evaluating historic architecture. And then the other material I found myself getting into is, pultruded FRP. Again, a lot of structural engineers didn't want to touch this initially because we were lacking design standards. And we're very risk adverse in our field. And hey, unless I've got a standard that's been adopted by the IBC, which has been adopted by my state code, I'm not going to touch this. Okay, well, if you understand fundamentals and you understand how reliability is built into our factors of safety, you can design with any material, right? What makes this it looks like steel, and it's actually a steel replacement. If it were steel, I don't work out quite enough to just be tossing that up in the air. So it's like 1/4, 1/5 the weight, just as strong as steel, but in one direction. And I think it's tough we teach a lot of steel design in college, and then a lot of structural engineers start off their career doing steel. Steel is an incredible material, and there's some very complex things to do in steel. But because it's an isometric material, you don't have to worry about having different material properties in all sorts of directions. Whereas with concrete and certainly FRP, you do. And so that makes the analysis a bit more complicated. But still, if we do a good job of teaching the fundamentals, how are loads generated? How do they follow through a load path? How can bolted connections fail? What are all the possible limit states? If you understand those fundamentals, finding the equations or coming up with some sort of reliable design is actually quite trivial, in my opinion. And I think we struggle when we're teaching college students or early career engineers to sort of walk that fine line between technician and fundamental scientist in understanding how design goes. And if people only know how to design structures through tables and equations and the provisions of the steel manual, then it is very scary to design with materials that you might not have as easy of an equation to apply. So we've got to teach the fundamentals. And I love this. I obviously have a big concern about corroded infrastructure. I live in the part of the country that unfortunately some people still associate with being called the Rust Belt. And we've got a lot of rusty infrastructure here. So, if you can use durable historical materials and keep them preserved or in great shape, or you can start replacing infrastructure where appropriate. This isn't a panacea, but where appropriate with non-corrosive materials like FRP, all of a sudden we're going to have infrastructure we're leaving behind for our kids, grandkids, and great-grandkids. And that's a wonderful legacy to leave as parents and professionals.
Absolutely. And as an owner of a firm, I'm a lot restricted with a lot of litigation about our designs. So when we have to carry insurance, and the legal industry likes to go after that insurance. So when there's upset or perceived upset, we certainly get attacked about our design. And the courts, it's pretty abusive to be in a courtroom where you're in an uneducated jury sitting there and you have the opposing side with their PhD engineers saying, that product should have never been used, that new product, and you've got a jury and you're being attacked. So I think that needs to change in the industry. We need to also be not only educated about new materials, but we also need to be protected more from this litigation insurance work, environment as a firm. We almost can't take risks because of that environment.
Exactly right. And so when you're working with these materials, I tell students all the time, a lot of students are told to follow their passion, right? And I do think it's important that you like what you do. But I actually tell our students, look, passion just isn't enough. And in fact, if you hate what you do, go do something else. But if you like it, that's good enough. What you need to do is be good at it and be willing to get better. And then when you get better, that's where the passion grows. I can't say I was passionate about this field when I was 22, but I am passionate now. And a big part of my passion is derived from being on code committees. Now, there is not anything more tedious or trying than being on a code committee. I'm not going to tell anybody it's as fun as going to a theme park. But when you can help protect the entire industry and encourage them to adopt the designing with new materials by developing standards and guidelines, and that you're making that impact, that's huge. Because you're right, there's a lot of risk aversion in here. What's the old saying? When the Hindenburg blows up, that's when you find out the names of all the engineers. The Hindenburg doesn't blow up, they might get their name in a handsome plastic frame put in their desk, right? We're like the long snappers in football. You only hear about us when something's gone horribly wrong. Otherwise, we're expected for things to go right. So we have every incentive to be risk averse, and generally speaking, we should. But I think that we, risk adverse in what way? On a day-to-day professional level, absolutely. Designing materials we may not be familiar with is scary, but what are the long-term risks to our built environment? We've got corroded infrastructure that's dangerous out there. How do we resolve that? So I think all we're doing is transferring the risk somewhere else.
Yeah, I agree, which leads the whole forensics industry, right? Yeah. As this old stuff starts falling down and people getting hurt, and here comes the forensics world, and our poor regulatory environment supposed to be protecting us from this aging infrastructure, and private sectors doing all kinds of weird things with buying properties and giving them to property managers, and profit-driven decisions regarding our building stock, and our unfunded regulatory environment supposed to be keeping track of it. And it's a little spooky. The future is a little spooky.
I'm glad you touched on the financial side, because that drives so much of our industry, and almost nobody knows anything about it until they've been in the industry for a couple of decades. Even on a given project, $1 at the design stage is not equal to $1 on the construction side to the owner or developer, right? And how does that play into design decisions and delegated design, which is become extremely trendy for a whole bunch of things in the industry, right? And unless you understand those drivers, you can't always resolve everything with a technical solution. And that's what I find for the young engineers that I mentor. One of the biggest things to explain, hey, we got this change order, so we've got to fix it and make this work. Okay, well, what caused a change order? What's the driver here? What are the contractor, owner, the other design team members trying to get at? Before we just jump into a technical solution, we may not even be solving the problem because we don't understand what's driving it.
Kevin, I have a question for you. And I fall into this almost dreamy space about, what we do and our value in the communities. And I have this curiosity with the current situation with environment, the built environment, our impact on the environment when we build things, maintaining what we have. And we have this political big pendulum swings now, this way over here and way over there. But I would say engineering, we're supposed to be delivering, or we make this promise to our citizens through the state regulatory process, but we make this promise that we're protecting life, safety, and welfare. And we make that oath, right? And my question is, well, if we're designing human convenience and we're protecting health and welfare, should we step up our responsibility that we as a design community in this country start leading that we're not going to allow that kind of design anymore? We're not going to strictly design based on lowest cost or lowest profit, that we're going to drive another variable and we're going to decide as a community of designers. Now, we're not going to look to a government. We're not going to look to the code. But we're going to take control as a community that we collectively have added a new variable about environmentally sound design, and that's the way it's going to go. What do you think about something like that?
That's a big question. I do have an answer, but I feel like I've been sucking the air out of the room. So I'd like to hear Miles' answer to that firstly.
You have not. I'm still thinking about back to when you held up the different materials and how I was like, dang, should I have gone into engineering? It's really interesting. Man, my first reaction to that is I love that. And I think we've done that in some ways. But how do you make that happen it's hard to make something like that happen in a greed driven, capitalistic, which is awesome in so many ways. But also, how do you kind of turn back once you've gone past that turning point, right? How do you go back and try to create that third variable where everyone is incentivized to do that? Because at the end of the day, we're humans. And, there's some ideas there, but it's challenging for sure.
You hit on the key word that I was going to say, incentives. So I think we can go to conferences and all agree about what the right thing is to do, but until you have the incentives, not just within our industry, as you mentioned before, Scott, there's a ton of financing and development factors that come in here that are way outside our design capacity, even if we want to do the right thing. Let's use a tangible example here. And this is one I give in class when I was asked to teach an interdisciplinary course on resilient engineering and building in floodplains and low-lying coastal areas, right? So in any given year, in many years, the majority of insured losses, keeping in mind that there's a whole lot of global losses to natural disasters that are not insured, and it's not to say that those don't count. In fact, they probably matter even more. But in most years, the majority of global losses, insured losses, are due to hurricanes in the U.S. Southeast. And about a third of those losses are on average associated with like half a dozen counties or so. And I don't want to be picking on a particular region of the country here. It just serves as a great example of what we're getting at. We are building and booming our population and subsequently our infrastructure and built environment in places that are very exposed to natural hazards. And so John Oliver, who does Last Week Tonight, about 10 years ago, and I still play a clip of this in my class every year, did a great breakdown of the National Flood Insurance Program and how there are basically perverse incentives built into that. And I don't think this is a panacea again, but premiums for insurance have to be appropriately aligned with the risk. And currently they are not. That's not going to solve all the problems, but I agree with what Miles said, which is I think you need to at least create incentives to target better construction decisions, which starts with where are we building in the first place? And by the way, if we are going to build in these vulnerable areas, is it more expensive to build a building a fewer feet higher than you might otherwise, just as a very rudimentary example? Yes, but what if it saves you $10,000 a year in insurance premiums for the next 50 years? Okay, well, all of a sudden I might be able to come up with a little more cash to build it right in the first place. So we don't, at the moment, we don't have a great insurance incentive structure to build the right way in this country, particularly in regard to floods. I think it's improving, but it's not there yet.
Yeah. Well, I just challenge ourselves to start thinking a little more leadership in how the built world goes, rather than just letting the dollar. If we're truly going to if we're truly going to respect our promise that's for protecting life, safety, and welfare, shouldn't we look at what's actually happening with the climate and global climate change as part of that process? And shouldn't we just start taking the leadership role rather than letting a really flighty government political environment tell us how it's going to go? Shouldn't we start stepping forward and taking leadership roles and establishing the standards ourselves, is my question, rather than letting the dollar, they have to go through us, and we're not regulated. We can do what we want as a group. Shouldn't we organize and do better, is my big question.
It makes me think of legacy, like, at the end of your life, all the work you've done as an engineer, looking back or showing your kids, talking to your kids, your family, did you contribute to the problem, or, did you have this ability to help along the way? And who knows what's going to happen? Certain things are changing pretty rapidly, like in the next decade, 2 decades and beyond. Who knows what's going to happen? But, we do have some control over that, and we all have a decision to make and how to do that. Standardizing it and scaling it is challenging, but just from your own personal, I don't know, I thought about that. Like, engineers are, I think, inherently proud of their work. It's a prideful profession. It's hard earned, it's hard work. And you're not, from what I've seen, like you said, you're the long snapper. I think that's such a good example, but you take pride in it because it's kind of like the unsung hero in a lot of ways. And you guys touch so much of the built world that people interact with every single day.
Yeah, and there's a joke on our industry. We do take great pride in our work, and I think to Scott's point, it is hard to find leaders in our industry for various reasons compared to maybe other industries where the inherent recruited pool tends to have a bit more of a leadership ambition, I guess. But yeah, somebody came up with a phrase recently called nerd sniping, right? If you want to distract an engineer, just point out that something they did was probably incorrect, and they need to dig back into the numbers and reevaluate it. You won't hear from them for a couple of days, and they probably won't sleep either, right? So yeah, we are very proud, especially when it comes to defending our designs. It's hard to keep us. I think that one of the hardest skills I can teach engineers is sort of that interpersonal client interaction. You will be called into meetings, all sorts of meetings, especially during construction, where somebody is criticizing the heck out of your design, right? And you need to, it's extremely hard because that was your baby. You stayed up late nights and came into the office on weekends to get it done on some ridiculous schedule, and now someone's telling you did it wrong. Learning to respond unemotionally to that is extremely difficult, and I'm not going to pretend that I did the best early in my career, but hopefully I've improved over time.
Yeah, 100%. I'm glad you said that. We actually have learned over the years, we do every other week a workshop, most of which are around those interpersonal kind of communication skills, some sales skills, stuff that isn't often taught to completion in the...
It's most of my mentoring.
Yeah, but it makes a huge difference in confidence, in ability to produce work. And it's awesome to see.
Yeah.
Oh, exactly. So when we created we've had a research graduate program for a long time, but we created our professional program, and we went to our industry advisors and said, what are the most important classes to have in this program? Number 2 was something soils and geotech focused. It's too hard to hire people in that field. You guys need to train more of your graduates to have an understanding of soil structure interaction and water flow through soils. Okay. But their number 1 request with a bullet was to have an interpersonal skills class. And I made the mistake early on of calling it a soft skills class, which really undermines the importance of it. It's the one course in our master's curriculum that no matter what technical concentration that you're in, you take it, because you are going to have a very low ceiling on your career if you cannot communicate your design intent and listen to stakeholder feedback in some fashion. Doesn't mean you have to be a politically savvy, shaking hands and kissing baby type person, but you need to be able to communicate. And if you can't, your best path is to be a back office number cruncher, and you're just not going to get very far in your career in terms of salary or career growth doing that.
Yeah. And ultimately, I think it's eroded us in our society about how our society and how we're looked at is we're made fun of almost because we don't have that skill set. And I think that would be a really important shift to make that more important in academia to go, I know your science, I know your math, I know you're in this thinking, but we've got to shift this thing where we're not made fun of or thought less than in our society because of that inability.
Yeah. Well, and there was a great article posted by two professors from Arizona State University and the Boston Globe just a few days ago. In fact, I have it pulled up here, so I'll at least mention their names to give them credit. So written by Ann Kirshner and Jeffrey Salingo about how higher ed can reinvent itself. And I love this article because if you're in higher ed right now, there's been some inflection points with the presidential administration change that everybody is rightfully anxious about. But I like their focus on sort of the meta trends. I like focusing on meta trends. I think you kind of alluded to this before, Scott, that one great thing about working in infrastructure is it really is nonpartisan. Everybody wants to invest in infrastructure. Whether or not we do that well or we're properly motivated is a separate question. But no matter, who's in power, there's always, infrastructure always seems to carry a positive weight, right? And that's good. I'm glad for that. Well, these two professors addressed the meta trends in higher education. And their focus was, they rightfully asked whether or not we're focused on properly educating people for their careers. And that doesn't necessarily mean we need to become even more siloed. In fact, it probably means we need to become less siloed. And I think the word interdisciplinary education has probably been overused. I like to look at it as this. Look, we know what skills people like us who have been in the industry for a while are required for good career growth opportunities. We need to teach those skills. And frankly, a good philosophy class that teaches students to critically think, evaluate very complex problems from multiple sides, and accept that there probably isn't an optimal solution in a lot of real world instances is a great class. No, it's not teaching them to design a reinforced concrete theme, but it's an incredibly important emotional intelligence skill that they're going to need to be successful in their careers. So how do we break down these perceived silos in our educational system in order to better prepare students for the real world? And it's not just a matter of doing the right thing, although that should in and of itself be a good inherent driver. It's what higher education needs to survive, because the current model that higher education has been operating on the past several decades is not going to allow it to continue into the new world. And again, I think that's largely, we're fighting meta trends here for demographics, fewer students going to and interested in going into typical college paths. If we want to get people into our industry, we need to first inspire them and then inform them, and properly inform them in a holistic range of skills, not just the technical ones. So I'm thrilled to hear that you guys focus on that a lot in your mentorship.
Holy smokes, we do. Yeah. I like the inspired word. Yeah. How do we inspire? Yeah.
You can't inform until you inspire. You can give the best technical presentation of your life, and the class will be half asleep if you don't give them a reason to stay awake and pay attention to why you're talking about it.
What a great comment. Miles, I'm going to ask you about something because you're early 30s, right? Inspiring. So I'm hearing through why engineers are quitting the industry. The second biggest answer, I think, was lack of purpose in the firm. They didn't think their work was purposeful. So what is purposeful for you as a young man in the United States, or representing your age group? What does that mean? What does purposeful mean? And then, so maybe Kevin and I can take away that and then try to influence going, okay, well, this is how we attract people into this space. How do we get more engineers?
No pressure. Just describe the drivers for an entire generation.
Yeah, just tell us.
Yeah, I got this.
Because we're going to run with it, whatever you say.
Right. Okay. Well, the first thing that comes to mind, because it's kind of a nuanced thing, right? Like, Kevin, I love what you said earlier. It actually really resonated with me. You don't have to love what you're doing. Just like it. You don't hate it. You can leave if you hate it. But if you like it, that's all you need. Because once you get your hands in there and over the years, you start to realize all these little things. It becomes a part of you. It's like a part of your essence now. That is purpose. whatever that thing is, but also just having, like, when it's all said and done, like the binary answer is solving a problem that you care about. So like for me, I do marketing and branding and all sorts of things. I'm not an engineer technically, although I love engineering and I've learned so much about it, through osmosis, but I've seen a lot of problems in the industry. I've seen, emotional issues with people and how it impacts their lives in a negative way and how it could easily or not so easily be fixed or solved with things I can think of or things that we're creating. So it's just that connection to solving a real problem, typically that, has some connection to your personal life as well. That's what gives me purpose. I'm sure if I had more time, I could organize that better, but that's kind of the gist.
Do you think people can find that, Kevin, in engineering and civil built world environment? Do you think people can find that?
Yeah, I've read a lot of articles about burnout in our industry and how hard it is to retain, although, again, I didn't know how low the number was until you mentioned it. And, it talks about tight schedules, demanding, overtime hours, hitting deadlines, getting feedback. Is that really unique to our industry? I think a lot of people in a lot of industries see that. What might make it potentially more stressful in our industry, particularly for young people, is the same thing that I think makes our industry so satisfying and fulfilling, is that we are playing a large part in the built environment. So you've got a building or a wastewater treatment plant going up and there are hundreds of people on site building it, and somebody calls you and says, oh, we need this redesigned and we need to hear back by the end of the day. Otherwise, we've got 100 people standing around and you're holding up a project, right?
Right.
So I think it's a double-edged sword of how fulfilling our careers can be in the built environment space, because there's also a lot of pressure for that, and people feel it. And it's hard not to take it personally. Again, if you are good at what you do, you're probably emotionally invested into it. And when you feel like you haven't done a good job, it's not just a professional critique, it's almost a personal one, right?
Very much personal.
And again, I've struggled with that throughout my career. I'm not going to say that I've always been above it. I certainly have not been. There are some conversations with contractors earlier in my year I wish I probably would have handled a bit better than I did. But I think what we do a terrible job of teaching in higher education in general, and I take personal responsibility for this, but I'm not the only one, is the absolute best way to learn is from your mistakes. I took I kind of viewed welds back when I was a college student as sort of magical. Well, if you get enough weld on there, it can hold anything, right? And I did not take a weld seriously enough on our ASCE steel bridge, and the thing failed halfway through the loading at the competition. And I had invested pretty much all my nights and weekends, and a lot of younger students were relying on me. And I just went into my car and screamed. Now, nobody died. It was a steel bridge. But that was, at the time, an emotionally painful experience for me. I can tell you one thing. I take every weld call out incredibly seriously in my career as a result. And it sucks, pardon the language, but the absolute best way to learn something is to fail. And the way that we structure classes and try to serve our students these days doesn't create enough opportunity for failure in the college environment. And as a result, a lot of young professionals are experiencing failure or perceived failure really for the first time in their lives. As one of my colleagues pointed out, if you've been accepted to a university like Notre Dame or an Ivy League that have ridiculously small admissions rates, you've probably never really experienced rejection in your life, right? Then you get A's and you graduate at 22, and all of a sudden you're a few years into your career and somebody's screaming at you on the phone because you screwed up a detail and it's holding up the whole project. It's understandable that people react strongly to that. I did when I was that age. So how do we teach better emotional resilience? I realize that sounds like something that should be handled by our liberal arts colleagues or our psychology colleagues. It's not. It is every bit as important as our field as it is in any other. And we are not doing a great job in higher education teaching that. I will pat ourselves in the back that we have created a first-year engineering discernment class called Build, Break, Perfect. And the whole goal there is to have students try to attain some sort of design goal with no calculations whatsoever. They've just got to build something, realize why it fails horribly after we break it, and then hopefully in a later class they'll learn how to properly design it. That's a small marginal improvement, but I think that's exactly the mindset we have to expand across our curriculum.
I tell Miles all the time, we got to come up with a sitcom, engineering sitcom, so that society has fun with watching us screw up and figure out and solve problems in the engineering built world space and just make it a sitcom. We need to invoke some investment because it'd be so much fun.
And I love that you're suggesting it as a sitcom, because every time there's a show about engineers, it's, greatest engineering failures, and 12,000 people just got wiped off the planet, right? Because some engineer screwed up the converting metric to imperial units or something like that. I agree. I think there's a more digestible way to understand failures without having to make it the Hindenburg disaster every single time.
Exactly.
I would love a sitcom. That would be great.
It would be super fun.
Yeah. You say, well, you can't make a sitcom about engineers. They're uninteresting. How many seasons of The Office do they have about a company that sells paper?
Exactly.
You could do that with an engineering office.
We could kill it. I know we could.
Yeah. Yeah. Throw in some fun subcontractor, engagement. It'd be a good time.
Yeah. Yeah.
I'll get to work. I'll write a script.
Okay.
Kevin, really appreciate your time. I know you're busy. Thank you for coming on. Thank you for sharing all this. There's so much we could have keep talking. Maybe we'll have you back on in the future if you're up to it to check in, but really appreciate you.
Yep.
I love that. It was an honor to be here, and I want to thank you guys. I know you each have your careers elsewhere, and this is just a side gig for you, but what you guys are doing here is incredibly important for the health of our industry, and then by extension, the health of our built environment. We need to inspire young people and tell them how wonderful it is, and admit that there are challenges, but they're all solvable. So thank you guys for doing this on behalf of all of us.
Oh, so welcome. And again, same as Miles, we're so grateful you had made some time, and love to have you on again. It'd be great.
Yeah.
Thanks for listening. If you found value in this episode, support us by sharing it with someone or leaving a review. In upcoming episodes, we'll discuss the realities of the industry today and what the future may look like. It's our belief that positive changes for architects and engineers is not the obligation of the industry, but rather a choice you make to reimagine how we work together. We invite you to join us in creating a world in which design professionals thrive. Learn about our mission and get involved by following us wherever you listen to podcasts and subscribing to our newsletter at leveldesignpartners.com.